Anyway, so first of all, good to see that there's still a full house pretty much for the final talk of the day before the drinks. So my name is Bas indeed, and I'm going to talk about how we do ranking in online grocery, and no point for guessing which online grocery that's going to be about. So just to start with a bit of audience participation, who actually knows about Picnic? Yeah, that's pretty much everyone, great. And who actually orders with Picnic? Well, still quite a good score, nice. So for the people who are not quite familiar, I will start with a bit of a corporate introduction. A mission statement, making grocery shopping simple, fun and affordable for everyone. Of course it sounds very corporate, but it does capture the basics pretty well. So this is more or less what it looks like. First of all, we have mobile apps, of course in Android as well as iOS. It's an online supermarket, so you can choose all the groceries that you want to buy. Obviously, we have quite a large assortment, something like 8,000 products, so you can't show all of them at the same time, so we need to make some kind of smart selection of products that we want to show. This gets delivered to your doorstep. We promise and also deliver in a very narrow time window, so something like 20 minutes, so you don't need to stay at home the entire day for your delivery to arrive. We have low prices, no delivery fees, and also this is done in a sustainable way. So you don't need to drive to the supermarket, but we actually deliver to your doorstep. And we do this in these nice electrical vehicles that you probably have seen around. So that's more or less the overview of what we do at Picnic. And that's more of the general background. Now I want to go into the more technical aspects. So I'm going to talk about ranking. So first of all, I want to tell a bit more about the app, what it looks like, and how ranking plays a role in different parts of that. Then I want to go into two specific use cases, which are very important in grocery shopping. One is repurchasing, and the other one is search. And then I want to wrap up in the end. So first of all, let's go into the Picnic app in a bit more detail. I already told you it's essentially a supermarket on your phone. You can select all the products that you want. Purchase, well, I think you need 35 euros at the least, and then we will deliver it to your home for free. But as I mentioned, there's lots of products and only a limited space that we can use in the app to show you products. So we need to be smart in what are we actually going to show you. First of all, let's just contrast it with traditional supermarkets. So if you think about your typical offline supermarket, everything is in shelves, and there's all kinds of opportunities that are not available for offline supermarkets, but things that we can do because of being online. First of all, it can be personalized, so we can actually show different people, different products, which might be relevant to them. It's searchable. Well, I think search is a very obvious functionality. You can search for coffee or beer or chips or whatever, and we will show you relevant products. So really the groceries come to you instead of you having to go all the way through the supermarket to find what you want. And also it's potentially responsive, so we can interact with you depending on what you actually do in the app, so we can show more information, we can show you related products, we can show you recipes, including that ingredients, and that gives us all kinds of new opportunities to do clever stuff. So in this talk I want to focus on a few parts of the app which are particularly important. So one is the purchases page. So if you think a bit about your own grocery shopping, if you go to the Albert Heijn or whatever, what are you going to purchase? Quite a lot of products are actually stuff that you've bought before at some point. And that's also the idea of this page. It collects all the articles that you've bought with us before. However, this quickly adds up, so for many customers this is hundreds of articles. So again, here you need to be clever in what articles are you actually going to show in the limited space that you have. And this is really about repurchasing. The other page I want to focus on is search. Again, search is a common functionality. You enter a certain search query, you get a bunch of products which are related to that. And there's actually a few different kinds of relevance that come into play there. So one is what kind of products are relevant to you as a customer, but also what is actually a good match to the individual search term that you use. And these two might be similar, but actually they're not necessarily. And also there might be other business considerations why we want to push certain products higher up on the page or not. What I want you to take away from this slide is that we have different pages within the app, which have different functionalities, and it also means we have different ranking logic that we need to serve to these different spots. And how do we actually serve that? So use different ranking logic in different places. It's actually quite conceptually straightforward. We just have a kind of a JSON, which is a ranking template. And the ranking template is actually, like I said, conceptually easy. It of course has a few labels like an ID and a name and all that. But the interesting part are these two. So we have the triggers, which tells you in what cases do we actually activate this kind of ranking logic. And we have the score distribution. So this gives us the option of selecting a few types of ranking logic, giving them some weights, and then combining them into one final score. Conceptually, makes a lot of sense. It's quite easy. But of course, it's also very useful when talking to the business, because they can very easily understand what produces a certain ranking on a certain page, what are the contributions to that, and it's even tunable by them if for whatever reason they want to make changes in that. So to give an example of what these triggers and these score distributions could look like. So there are also JSONs. For example, it could be activated for if people search and end up on the search page and use a specific search term, like olives, for example. In that case, we will serve a score distribution, which is a linear combination of two rankers with some logic behind it, with different weights. And that way, we can really tune the individual ranking logic in different parts of the app. So now I want to go into what are these rankers actually? What is the logic behind rankers in different parts of the app? So first, let's focus on rebuying. So again, the purchase page is the main part of the app where this is facilitated. So to recap, it collects all your articles that you've bought before. This is often tens to hundreds of articles. People don't really like scrolling. You probably don't either. So people tend to convert pretty well from the top of the page, but not so much if they have to scroll all the way down. So what do? We need to rank in a way that makes sense. So people that, if you're likely to convert for a certain article, then it probably should be somewhere at the top. And the ones that you're unlikely to buy in your next delivery should be all the way to the bottom. So what we do is we rank on predicted next basket repurchase probability. I will go into a bit more detail later on. So this is supposed to be an animation, but it's not. So just imagine it's hilarious, but let's go on. What we have as a model is something that we call CARP internally, hence also the picture. It stands for Customer Article Rebuy Prediction, and that's really, I think, summarizes what it does. On an individual customer level, and for each article, we want to calculate a score, how likely is the customer to rebuy it in the next delivery. So there's of course some standard data stuff happening before the features. So we look at historical deliveries, we make a train split and test split and all that kind of stuff. But the interesting part happens afterwards. So if we look into the features, of course the purchase history of the customer is an important feature, right? We can add all kinds of article properties, customer properties, etc. We need to take care of seasonality and unavailability. But I really want to focus a bit more on what we call product purchase periodicity. And that's really about rebuying intervals, rebuying patterns for articles. So just to illustrate in a cartoon how this looks like. So we have purchasing for a few customers and two products. So we have bananas at the top. And bananas is one of those products that sell a lot and people can often rebuy it quite often. So you can see that as well in these past deliveries of these few customers. And if you contrast that to shampoo, for example, at the bottom, this gets rebought far less frequently. So what you can do is you look at these rebuying intervals. So if you buy it now, what's the next time that you will rebuy it again? And then look at the distribution of that kind of quantities. So if you do that for bananas, for example, and you average over all customers that rebuy bananas, you will see that on average, for example, they will rebuy it every 1.5 deliveries. For shampoo, this will be a much larger number. And that's already an important feature in our modeling. Just an article level measure of how likely people are to, well, at what intervals they like to rebuy it. Of course, you can also do this at a customer level, which gives you even more information. Some people might rebuy these products very often, others less so. And you can imagine that if you combine this with purchase history, this actually gives you a good indication what's likely to be rebought and what's not. So for an actual customer, this looks something like this. So this is for a type of milk. Horizontally, we have the week number for all delivery, well, yeah, all weeks in 2022, and the weekday vertically, so Monday to Sunday. So the light blue squares means that there was no delivery at all. On the light blue squares, sorry, dark blue squares, the customer had a delivery with this type of milk in it. And for the red squares, they did buy a similar type of milk, but not quite that article, but something similar. What I would like you to take away from this picture are a few things. Of course, there's quite a bit of article loyalty in repurchasing. However, customers can switch to related products either intermittently or permanently, and this needs to be reflected in the features as well. So we don't only look at article repurchasing, but also category level repurchasing. And finally, if you look at the kind of weekdays this customer likes to order in, there's quite a lot of structure in that as well. Customers tend to prefer the same weekdays, even though it's not the same weekday all the time. But there's definitely a preference for early days, for example. And this is also something we can see in the next slide. So this is more of a sciencey slide. We look at the distribution of these rebuying intervals in time. So what we really see here, so we look at, again, milk, and we look at laundry detergent, which is something that you don't tend to rebuy every week. And you really see peaks here at 7 days, 14 days, 21 days, etc. And that's really this weekly rebuying pattern where customers tend to prefer to order on the same weekdays. The second thing I would like you to take away from this is that the shapes actually look quite different from something that you buy very often, like milk. And they see a very quick decay, lots of rebuying after 1 week, but relatively speaking far less for the weeks after. For detergent, it's actually much more of a long tail. People don't tend to rebuy it 1 week later, but it can be 3 weeks, 5 weeks, 10 weeks later, quite easily. This is actually more or less the same data, but now we actually look at rank. So simply the first delivery, second delivery, third delivery, etc. Instead of looking at it in days. And we have a logarithmic axis vertically. And this shows you two things. One is that if you only look at sequences, you actually lose a lot of information. So you lose this temporal structure that you clearly see if you look at real timestamps. And secondly, it's even more obvious here that there's actually a long tail for repurchasing. And that also means that if you actually want to aggregate this into one number, you probably shouldn't look at averages, but a median is much more appropriate. So in summary, for this kind of feature, you want to use both temporal and rank-based quantities. It's heavy-tailed, so probably you should use medians for these kind of quantities. And also, mostly from the previous picture, not only article repurchasing is important, but also category level. So that's more or less added here to the features part. So for the model part, as I already told you, it's more or less binary classification that we do. We want to see, is this article bought in the next delivery or not? In practice, we actually use this, the probability score of how likely that label is as a measure of the conversion probability. And it turns out it actually boosts what is classic models actually works pretty well. And compared to the other models that we've tried, it's the best performing one. So how do we evaluate this? In the end, we make a ranking out of this. So actually, order is important. We of course also look at other metrics, but the main metric that we actually focus on is something that's rank sensitive, the mean average precision at 30. And the 30 is related to the fact that the purchase page shows 30 products individually in our implementation. More technical note, we've checked that this model is well calibrated, so actually the class probability is pretty much the same thing as the conversion probability. And it makes interpretation quite easy also for the business. And of course, this is not just some kind of theoretical model. We actually need to know that this works in practice. So we've A/B tested this extensively, and it actually works a lot better. We have increasing conversion, and also people tend to add from higher up in the page as compared to previous logic. All right, so that was my section on repurchasing. Now let's go to search. So I've already mentioned search a bit. So the subtitle here is relevance in various guises. What I mean by that is that there's different ways of relevance that play a role here. So one is this repurchasing behavior, which tells you a bit about how relevant is this article to a customer. But also we have a relevance to between the search term and the article. How good a match is that? But first, let's go into what happens in search within the app. So what actually happens on the back end? So let's say we search for cheese. So what happens is that you enter it into the app, and then it gets sent to a service called Elasticsearch. And what happens in Elasticsearch is actually that it tries to match the search query CAS to all kinds of article properties, things like the article name, things like the supplier name, category name, etc. It gives a certain matching score, and in the end, we end up with a certain set of cheese-related articles. And then we need to rank this in some way, right? And of course, we use these ranking templates to actually do that. So we have a bunch of scores that we use, and we need to define what kind of weights do we give to each of them. And that, of course, will result in a final result set. We see a bunch of cheeses, and I think for cheese you will have tens of results easily, probably 100. And this is ranked in a certain way. And of course, the question is, in what way? So let's focus a bit on these ranking templates. But as you see, I have 3 icons there, and there are 3 different types of ranking logic that we might want to use. So the bottom one is one that I've already discussed. So that's really this customer level rebuying probability. The second is some kind of boosting factor. And this is intentionally very generic, but it's some kind of reason why the business would want to push up certain articles. This could be because we have lots of stock of a certain article. This could be because it's a new brand that we want to push up higher up in the results. But for whatever reason, we want to push this up into the ranking. And the final one is the search term article relevance. And I want to spend a minute or two explaining that. But it's really a measure of how well does the search term and the article match. So of course this is related to search conversion, but it's not quite as trivial as that. So if you look at search conversion, there's a complicating factor called position bias. And I think most of you will have heard of position bias, but it's also quite intuitive. So if you look on Google, for example, and you search for something, people tend to click very much on the top results. They don't want to scroll all the way down, and definitely not to page 2 or page 3. They look at they click on something that looks kind of relevant and is in an easy to reach position. This goes both for inspection, so people tend to inspect mostly the top results, but also simply the fact that it's rated on top already gives people a bit of more trust in the relevance of that article. And this also happens in search conversion at Picnic as well. If you put an article on top, it's more likely to get converted than if you put it further down, even though it might be more relevant. So, as a former physicist, I put a nice formula at the top right. And this is more or less how likely is a customer to convert for a certain search query, for a certain document, which is equivalent to an article in our case, at a certain position. So we decomposed into 2 factors. So at the top right, so this R is the relevance, and that's really this search term article relevance that I'm talking about. And that's really how relevant is this article to the actual search term. However, this gets weighted by the position bias. So the position bias is normalized in the sense that we set the relevance for the article in position 1 to 1. And then it goes down, which basically means that if you put it instead of the first spot in the second spot, it will get only something like 62% of the conversion. And the further down you put it, even though the relevance doesn't change, the conversion will change. So what we actually have is a systematic way of calculating, or at least estimating, this position bias, and calculating a debiased relevance between the search term and the article. So that's the star score. So those are the three ingredients that I want to talk about. And then, of course, we want to make sure, or at least want to try, to predict these different weights in this ranking template to find the optimal ranking. Of course, optimal, again, is not really a very well-defined term. Again, there's a balance between different relevances. And also, from the business side, there might be other things at play. So that's this boost factor that I just introduced. We might want to push up certain articles because of profitability or because of availability or whatever. So we've actually set up something conceptually similar to what I talked about before. So we estimate a relevance score, but now not just on a customer article level, but also for individual search terms. And that's, again, based looking at past deliveries and seeing what gets converted and what not. And then we can actually calculate what's the expected value of this boost that we have. So again, we have, to make sure this is actually the expected value for the boost for a certain ranking of articles. So for a combination for each article in a certain position. And then we can calculate what's the expected value of this boost quantity. So again, we have a relevance, which is dependent on the search query and the article. And we have the position bias that we need to correct for. And together, this gives you a conversion probability. And then we just use that as a weighing factor for the boost. And that way we can actually find for what ranking, so what combination of articles and positions, we actually get the highest value of the boost. You could, of course, think, well, why not use that directly into the app? There's a very technical reason for that, which is simply this is a lot of data. So we have lots of customers, lots of articles, lots of search terms, so that data quantity kind of explodes. And that's why we actually approximate this by, again, a linear combination of these scores that we already had. And of course, that also gives you the benefit of this explainability that we had before. So what we do is we simply do a numerical calculation. We look at what's the best combination of these three scores, so the star score, the carp score, and this boost. That gives you the same kind of ranking as, well, whatever gives you the best boost factor. Of course, we've also tried this out in practice. It's kind of ongoing still, but still, initial results look quite good. Of course, I've removed all the actual numbers, but I think the overall idea is still quite clear. So we have two baselines, which is the two leftmost ones. And this ranking is purely on carp or purely on star, so only on search term article relevance or only on personal preference. Then in light purple, we have the current business rankings. And these are really inspired by what is, according to the business analysts, what's the best combination that we should show for a certain search term. And we see that indeed we structurally outperform all these baselines and the actual production rankings that are used. So both in MRR and NCG, which are the metrics that we look at. So this is a pretty good way, I think, of making sure that we can balance this boost factor and actual relevance to the customer in some optimized way. All right, that brings me to the summary. So first of all, online grocery allows for new ranking opportunities, which I think is obvious but good to state explicitly. Relevance is something that's different between different pages, and there might also be difference between customer relevance and company relevance as well, for example. The ranking templates is an easy and explainable way to mix and match ranking logic in different parts of the app. Next, basket prediction, so carp and also dbuy search relevance, star, are both crucial ingredients in making these rankings. And still a bit of work in progress, but it's certainly feasible to optimize these search templates structurally. And with that, I would like to finish with this obligatory company slide. Of course, we have to thank lots of people, and we have vacancies as well. And with that, I would like to thank you as well, and happy to take any questions.
Thanks for the very interesting talk, Bas. Any questions? Many. Let me start.
Thank you. Hi. I'm not a user of the app myself, so it might be there might be an obvious answer from other users. But I was wondering whether you also do like real-time updates in the sense that ranking updates in the sense that when I select my pasta, the cheese comes up, etc. Because you've been talking about basket updates, but how about that?
Very good question. Actually, we do not systematically, and the problem is really more technical. This is all updated in batch, actually. So every morning this gets recalculated, but doing this on a real-time basis is, most for technical reasons, not implemented yet, but it's a work in progress that we are working on. There's also an additional reason, which is that there is actually some value instability in ranking if you use the app. So you don't want to reopen the app and then suddenly your ranking gets gets updated for simply because there's been a rerun in the meantime. Yes?
Really cool talk. Happy to see Elasticsearch is being used still. What type of products do you struggle the most with? Like new products?
It's a good question, actually. So seasonal products is a difficult one. So what happens sometimes with Papernote, for example, is that they are in season for 2 months, whatever. Then they get out of assortment all of a sudden, and then at some point in October or whatever, September, I don't know, they are in assortment again, and then you actually want to show them. But if you're not careful, you actually push them all the way down because they haven't been rebought for a long period. So I think seasonal articles is a big one. And related to that is if there's been systematic unavailability. So as you might know, there have been some supplier issues all over the country with certain brands. That's also something that pollutes your data because it looks like customers don't want to buy something, but they couldn't buy it. So I think those are the two main problematic cases.
Aren't Papernote like half a year by now?
Yeah, probably. Asperges, whatever.
Do you adjust for holidays and such?
Not so much in ranking, actually, no. We do, of course, have all kinds of holiday corrections in forecasting, in product purchases, etc. For ranking, not so much, no. But of course, there's because of these templates, we can actually have the business define boosting factors, and they do that for certain seasonal products, for example. But that's more of a manual process.
Thank you so much.
Yeah, welcome.
Hi, I was wondering how do you deal with the cold start products?
Yeah, so for carp it's actually easy in the sense that we focus explicitly on rebuying. So there's no cold start in the sense that if it's included, you have bought it at least once. But of course, it only gets reliable once you've rebuilt it once. Sorry, yeah, if you've rebuilt it once, so bought it twice in total, then at least we have some kind of estimate of what is the rebuying interval that is relevant to you. So what we do is we have fallbacks to this article level rebuying intervals. That is our best guess for you if you've only bought it once.
One last question, and closest to me.
Hi. So, as per the recommendations, I feel it's more like content-based recommendations. So, do you take into consideration collaborative recommendations as well by looking at what people from a region are ordering, or is it more like always, what did you buy the previous time?
Yeah, so this is indeed very much content-based, so it's personalized, but only at an article level. So there's no collaboration effects in here. There's actually something that's actively being investigated at the moment to also get these more article interactions into the recommendations as well.